Well, hello everybody. Good afternoon. Thank you for showing up for the last session. I realize I'm the last person standing between you and the great Ask the Experts, which the highlight of that is pretty much beer. So I hope there's going to be beer over there, but let's work with that. Okay, so welcome to Building Modern Cloud-based web application, web and mobile application on Azure. My name is Yochai Kiryadi. I'm a principal program manager. I've been working with Azure and specifically Azure App Service for 5-6 years now. The technical evangelist before that and a bunch of other startups. Our team, myself, blog a lot on the App Service team on MSDN. You can see all kind of technical stuff that we do with our team. That's my Twitter account. If you want to find me on my email over there, and we'll have this slide at the end of the session as well. So, yes, let me just ask. How many of you are using Azure App Service or Azure websites? Okay, just about a third. Cool. So for those of you who are not, welcome. We'll dive into that pretty much this entire session. For those who are, maybe the slow will be a little bit boring. Anyhow, if you have an Azure account, great. You can go ahead and actually can follow up some of the stuff I'm going to do. And if you don't, you can go to tryappservice.azure.com. And basically, if you don't have an Azure account, this will allow you to experience some of what I'm doing right now in a controlled environment, no credit card. Just put your email and you'll be able to work with it. But if you do have an Azure account, feel free to just work with it. All right, so application development have been changed quite a bit in the last couple of years, I would say decades. From physical machine to virtual cloud infrastructure, and now basically we're getting to the point where some of the applications that we are looking into, we are actually natively building and directly going against cloud infrastructure. Not necessarily a virtual machine like cloud infrastructure versus VM scale set or VMs or containers, but more of developer platform as a service. PaaS, serverless, all of this is where kind of we're trending, and App Service is exactly in that crossroad. So to try to kind of put things in perspective in terms of analogy, imagine that basically hosting a cloud will be like owning a car. So there are several options, right? You can own your own car all the way to the left, I guess, where the IaaS thing. And basically, owning a car, you need to buy the car, you need to finance the car, you need to regularly change oil and all that. So this is like owning a VM. You need to manage the OS, patch the OS, do all the builds, everything around that. All the way to the other side, you can take a taxi, you can take an Uber, basically a SaaS application where you don't really have any skin in the game. You just use it, and that's it, and you're done. And you're probably going to pay a premium per usage, but that's OK. Where we fall with the PaaS model is basically, hey, this is somewhere in between. This is me telling you all you need to take care of is really just writing your code, understanding your application, knowing a little bit about the platform that you're running. But we're going to manage all that platform for you. You don't need to patch it. You don't need to patch the OS. You don't need to manage the OS. You don't need to manage scale. You don't need to manage your frameworks that you're running on. Just deploy your application, and that will work. That is kind of where PaaS is in between. And it's mostly just basically a question of trade. Trade of what do you want? Do you want more control? Do you need more control? Do you need to own the entire thing as you do it on-premise? Do you need to be able to custom the OS for whatever reason? If so, then you need to basically go to infrastructure as a service, run on VMs. But if you don't, and you're willing to make this trade-off, basically that someone else will take care of the OS for the middleware for you, for the runtime, then basically you're probably can fit very well into the platform as a service model, which is where App Service sits. And the SaaS, obviously, it's as we say, it's all together. And Microsoft has a lot of SaaS options around Office and Dynamics and so forth. So what is Azure App Service? So Azure App Service is a fully managed platform. That's the beginning, like the black thing, black pillar in the middle. It's a fully managed platform. We take care of all the underlying infrastructure, meaning that you don't manage any OS, you don't have access to the OS, you don't patch the OS, you don't put up frameworks on the OS. We take care of that for you. Furthermore, when you deploy, if you're running on 1 VM or 10, we're going to make sure that your application runs across all of them. You don't need to deploy one by one, so we do take care of all the automation for you. When you run at high scale, when there's a lot of traffic, we'll do the auto-scaling and automatic load balancing across multiple VMs. And if you have many applications across multiple VMs, again, we'll take care of all that for you. There are some enhanced features. We'll see some of them. There are staging environments, backup and restore. There are security considerations. There's a lot of stuff that is come with this fully managed element. On to the left, enterprise grade, sorry. Basically, everything around security, compliance, hybrid connectivity. You can run within a VNet. You can safely connect to on-premises, global footprint. There's a way to protect your endpoints, bunch of stuff. And over to the right, which is kind of the most element part for developers, is where we got high productivity development environment. We offer you basically a lot of framework that you can run. .NET, obviously, but we support Java, Python, Ruby, not Ruby, sorry, Java, Ruby on Linux, but Java, Python, Node, PHP. We have experiment with Go, Ruby run on our Linux containers. So we have an ability to basically bring any framework/language that you would like. We include built-in infrastructure for staging. So when you deploy, you can deploy into a stage environment, run, make sure that everything testing and working properly before you switch into production. We can have something called testing in production, in which we can actually split traffic and says, hey, you know what, 97% goes into production and 3% going to this new version. And you can test it out and figure out how things works and so forth. We have app gallery, we have marketplace. There's a lot of stuff that actually help you get up to speed really, really quick. So that's app service. And app service basically includes multiple options or multiple application type, if you want to call it. So we have web, mobile, API, logic, and functions. And we're going to go through each one of them, and I'll show a little bit of example. So web apps is the original incarnation of app service. Used to be called Azure Websites, if anybody been using us that long. And it is basically the core construct that all of the other services are running on top. It basically has all the developer productivities, features, source control deployment, CI/CD, which we'll see, staging deployment, auto-scaling, monitoring, alerting, all of that. All the different framework and applications that are running on that. You can see here several of applications. If you want to run on Bruco or Sitecore, Orchard, or WordPress, you can just go ahead, double-click, not double-click, a few clicks basically get a full working deployment. As I said, all of the languages. And we support a lot of enterprise workload and industries running. We connect to Azure AD, and there's a lot of stuff in there. So, because most of you didn't raise their hand if I'm asking, when I ask whether you're using app service, let's see basically the hello world of app service and just how thing works. So with that, we're going to switch here. Another one. Fine, we'll do it here. Basically, we'll create a new a new website, a web app. Let's call it Chicago Demo 1. I think I already have 2. Okay, works. This is my subscription. I'll use an existing resource group. These are all constructed within Azure. Resource group is a container. We'll see it a little bit later for all your resources. Basically, it's a logic definition. This is the location I'm going to create. I'm not going to add up inside, but you can choose to edit or not. You'll see a little bit later why you should edit when you create applications, but not for this demo. I'm going to go ahead and create. Had some internet issues earlier. Let's see if it works. But basically, it will take about, 30 seconds, give or take, maybe more. But you'll have a container in which we will be able to go ahead and deploy our application and just have the thing work for us. And we'll see. So we'll give it a second. Anybody want a joke in the meantime? It should be a short joke because it is. It's done. So with this, basically, what we have created is a web app. And I'm going to basically show you that this is the first time we're running the app, so it'll take a couple of seconds. But this is it. This is a running application. It's an empty one. There's not a lot in there right now. We'll get it fixed in a second. But this is it. ChicagoDemo2.AzureWebsites.net. And you have a full working application. Okay, as I say, it's an empty one. I can open Visual Studio and deploy whatever I want. I'll go ahead and show some of the parts of the items I've talked about. For example, deployment options. So I'll go ahead and choose deployment options. And I'll configure one, and you can see we can connect to Visual Studio. Team services, obviously, the online service, the Azure service for basically building a pipeline, managing your entire pipeline and DevOps. You can deploy for OneDrive if you really feel like it. Local Git, GitHub. I'm going to just go with GitHub. And hopefully it's remember my credentials from before. All right, so it does. So it does remember where I come. Let's choose a project. And we are going to go with the first one. So this is just a really simple node application. It has only one branch, master. Just keep with that. You can already configure performance tests to be deployed together with your application. More applicable if you're running on a stage environment, but let's leave it aside for a second. I'll hit OK. And what we're doing right now is basically we're telling the system, hey, I want to hook up into a Git repo, which we just did. And what will happen behind the scene is that now the framework, basically the application, will go ahead and pull the Git repo that I have and just deploy it for me. And let's see the status of that. So as you can see, it's already hooked into Git, and now it's just deploying. So it takes the first deployment, specifically for a node application, takes a little bit of time, maybe about like 40 seconds, maybe 50, because you need to do all the NPM, which we're actually doing, and I can show you the logs. But it will be done in a second, and then we can actually see the app. So while we do that, let me go ahead and already prep the next part of the demo. I think it's here, maybe. Yes, OK. So this is basically the repo I'm working on. You can see these are, I hope you guys can see. Can you see at the back, or do I need to zoom in? You can see me basically doing some testing tonight and this morning. So the only thing I'll do right now, just to make it simple, is I'm going to fire up Git. Already got Git. That's good. Run code, VS Code, because this is a JavaScript app. So this is coming up. Let's see how OK, so it's basically done. You can go ahead, refresh the site. And voila. All right. So this is it. And so this is a very simple site, but I'll show you how we can change and update it. But I just want to show you really quickly what we're doing is it took overall 49 seconds. And basically pull up the information and see exactly who's the author, the GitHub, the status, the success, and so forth. You can see here what I want to show you is like running the deployment command, because this is the first deployment. So you'll be able to see the entire log. If you're familiar with Node, you'll be able to see like, hey, we're actually running, we're identifying what we need to run here, and we are doing npm install to basically get all the packages and dependencies. If you had a NuGet, a C# package, basically, and we would discover all the NuGet dependency, we will basically, download all the NuGet dependencies and compile on the fly and run it for you. So all this done basically is being done for you, will allow you to create continuous deployment and automation with the app. So just to finish the demo, let's go to our right. I'll just zoom in so I guys can see better. All right. So this is the app. Basically, this is a very simple Express app. I got routes are basically the controller. So here's the controller I'm rendering. I'm setting up some parameters like title and text. And I'm saying Azure Service, and it's going to go ahead and says add here. Take some demo. Cool. We'll save. This is the view, so overhead here, let's add another one, new line, and save this as well. Okay, so now what I want to do basically is git add. I'm adding everything. I'm going to do git commit, let's say live demo. All right, there we go. Okay, and now let's do git push origin and master. Why not? Let's just go all the way. Sorry. Get up the center. Now I pressed. Okay. So that's it. That's all it took. Basically, we'll just push deltas and they're up. And with that, I'll just show you how the hook works. Get away from this really quick. Back here. If I'll go ahead and refresh this view, you'll see that it already picked up my comment. It already picked up the latest version. And if I'll go here and refresh, basically, the changes should be visible right now. Ta-da! All right, cool. So that was very simple. It was a very simple app. It basically this is the hello world we're doing with App Service. So this is how you create, manage your application very easily. Okay, mobile application. Basically, we have a set of mobile SDKs, a set of mobile services that allow you to easily integrate mobile application. That's why I have my Mac here. We'll see a mobile demo a little bit later. But we support features like offline sync. We use a lot of user authentication, obviously for Azure Active Directory, but as you can see, a bunch of other providers. We can do push notification across multiple platforms. And basically, Azure Mobile Services with the mobile SDK is the only mobile provider out there that supports connecting to a SQL database and support offline connection against SQL database. So we'll see how that works in a second. We also have API applications. An API application, basically, we have a lot of what we call web apps that are being exposed as web API, and basically all the features for web, mobile, and API are available across all of them. This is more of a marketing definition. But specifically for web, we have features like easy auth, similar to the authentication model that we've talked about. We'll see a demo later on. We have CORS, which is super important for the function piece of the data. We expose the Swagger. We actually allow you to actually build Swagger, and we help you with building the Swagger. It has very good integration with logic apps and API management. All right, so logic apps. Logic apps are, anybody been to the logic app session? No? Okay. Logic apps are basically the easy way to envision them is like a managed workflow. And the next slide is a demo, so we're actually going to see that. But the nice thing about Logic App is the ability to be able to connect through multiple connectors. So there's a lot of connectors built into the platform. They're actually API-based connectors, so that's why the API apps are there. But I'll show you how many connectors we have. And the thing is that the platform manages all of that for you. So you don't have to do the authentication, song and dance, and the tokens are being refreshed for you and all of that. It's basically can cut across on-premise and the cloud. There are gateways connectivities that you can do through there. So you can have workflow actually running in the cloud, but fetching or managing data across cloud and on-premises. Has a lot of automation built into it and integrates very well with a wide variety of Azure services, including app services, APIs, and functions, which we'll see in a second. But with that, let's see a quick demo of Logic App. It doesn't matter which one we go. So Compressor is an example. We'll actually dive deep very much in few slides, but this is a good example for me just to show you how does a logic or just how does a logic app looks like. So as you can see, first glance, you can see some status information like reporting, like what happened and what ran. And this will give you basically an ability to view the run. So you see it looks like a workflow. There is like steps in here. There is a condition that you can do and all the information. You can see fails or success status. You can rerun the information and you can dive to a lot of data into it. You can actually go in a lot deeper. You can see raw input and output information, like all the information that comes in and out, and so forth. All right, so there's a lot of traceability in the debug into that. But the more interesting aspect is actually I want to show you the designer itself. which show, again, a very similar view, but this is how you can see the flow. So there is a request here. This request is being triggered from HTTP, but you can trigger from a lot of other endpoints. It flows through. You can see it calls function a little bit, and there are some state management. You can sending an email as an example over here. Let's say I want to take another action. And what I want to show you here is like the wide variety of managed API. These are managed API, managed connectors that Microsoft maintain. The ability to connect to a lot of providers out there. Doing some XML transformation, it's one thing, but you can do you can do queues, Azure queues, but you can do other services like Blogger and Box and Buffer, and the list is really, really long. You can see, you can scroll for very, very long. Obviously, a bunch of Office and Dynamics, but a lot of services. Salesforce, if you guys seen here, SharePoint, SAP, so forth. Nice thing about it is this can connect, as I say, to multiple APIs or multiple services. So obviously with managed connector that we have, any API on App Service, as I said, App Service exposes API, so you can connect with those. Any managed API through APIM. APIM can also manage API. Any other logic apps, you can nest logic app. You can think about it, it's quite a nice model. And obviously you can, connect to Azure Functions, which this is this demo, but we'll see it a little bit later. Just wanted to show you a little bit how functions look like. Logic app looks like. Okay, so we'll just ignore this and move on. Okay, so that was Logic App. And, sorry, too quick. Functions. Yes, so the next step is function. Function is serverless compute, basically, event-driven serverless compute. It's great, but it's easier just to show it, basically. But we have a slide about function, which I'm going to show you a real quick demo. But the idea behind function is that you don't even need to, with App Service, you build your application. You saw Node, if I have a Node application like Express, or I have an MVC app with Visual Studio, I can go ahead and deploy that. Cool. With function, we're even taking away that part. We don't even need a framework. We're just asking you, hey, give me raw code in a function form that we can run you that handles events like HTTP triggers, like queue event, like item in storage, like something happening on a subsystem in Azure, to any kind of operation, and we will trigger that piece of code for you and run it. So I think I'll show you really quick how it looks like, and later we'll just dive into some more complex function scenarios. So go here, function. So what I want to do is, let's go here. So I did a whole session just about functions about 2 hours ago. This was the hello world, so I'll just dive here, I'll make some small changes and see how it works. Okay. So imagine you have not seen this. Okay, right. So now that this, okay, so we're back into function. So here it is. So I created a function app, which basically is just a place for me to run multiple functions. And what I want to do, I want to add a new function. And this new function will just go ahead, and it doesn't really matter which JavaScript does because we can. And we'll say, hey, you know what? I want it to be HTTP triggers. So basically expose an endpoint. An HTTP endpoint that this code will run anytime we're going to hit that endpoint. So this will be the demo. I create the function, and the function is created. That's it. And now all I need to do is just copy paste this URL, go here, paste it in, and that's it. And you have an endpoint working. And that's all it took. Basically, create a function app, which I already created, but it's just like create a website, so you can see how quick it is. And then go ahead and basically this is an HTTP trigger. You can have other triggers. We'll see like queue triggers in a second. And it works. That all it took basically to create a function and expose it. The nice thing about function is we have something called bindings. And what are bindings? Bindings are the ability to basically control a little bit our input-output. What do I mean? So obviously, you see here triggers. A trigger, we have an HTTP trigger. You can create different triggers. For example, if there is a queue message, which will be the next demo, blob and Azure blob items, or any files or any object basically into blob, event hub, IoT, what else? We got a few more, forgot. And then we can add input and output as additional, but let's just do it for a second for an output. So for an output, what I want to do in this example is basically show you what we can do with the binding. So input-output binding is a way for us to abstract this data layer. What do I mean? Let's say I want to respond to the HTTP message that came in, take it, create some object, and put it on a queue for a later process. I want to create an async model that someone else will process it. Okay. All I need to do is basically says, hey, I want to write the message to a queue, and as you can see here, there's a bunch of other stuff we can do. As I said, blobs, DocumentDB, external files are like Dropbox or Google Docs. We can also even use SendGrid or Twilio, which we'll see in a demo later. But let's say I go with Azure Storage Queue. I hit a select. Queue, we want to actually work with this guy. Okay. Hit the save, and that's it. I created basically a binding that I can work with. The nice thing about functions, we really want to make you very productive and really quickly to get to results, so we embedded documentation within the portal. Beside the fact that we can tell you how to go to access or view your storage because using Queue, we actually show you what does it mean to work and give you code examples and all of that, which is kind of cool. All right, so I go back to develop, and I'm going to do something really simple. I'm doing just something really simple. I'm basically going to say context dot bindings and output queue name. So basically the output that we've talked about. This is the parameter that we are talking about. So we're just I'm basically going to say like hello world demo. And that all it takes to actually take a string or any object that I can serialize into JSON at this point and put it in an Azure queue from Azure Functions. And let's say hello tech summit. Okay, and this will go. Hit the save button. So you can see here basically this code. If I run this code, if I refresh it, it basically says, hey, you need to pass a name parameter query, because if you quickly look at the code, basically this hello world sample that we have here is requesting a query parameter or a body object if you're posting to have a name object. So let's just add name really quick. And as you can see, I made a change, I saved, and it's running. That's it. And by the way, it's also saved some item into the queue. Let's add some more. Maybe I should probably add, like, let's do something else. Since we know we're passing this, so we can see different messages every time. Okay, so now it actually will append the name itself. So if you go here and write Chicago 12, never mind. And cool, so it's submit here. And now I need to just show you that actually end up in a queue. So let me just do that. We took away the, yes, we have. Okay, so basically this is the queue name that we are writing to. It's all by default. If it doesn't exist, we'll create it for you. So let me go ahead and create a new function now, and I'll do it in C# instead of JavaScript. And we'll go with queue trigger. Where's the queue trigger? Queue trigger. And the queue item that we are listening for is this. I'll hit the create. And basically, pull up the logs real quick. Hope it's not too late. Basically, we're already in queue some items, so we should be able to see logs, but maybe I missed that with the half a second that it took me. Then go ahead and queue some other stuff over here. And here it is, yeah, so it already cleaned the other stuff. But this is the second function, right? This is a function that listens on queue item, and whenever there is a queue item, we will invoke that function for you. So we are constantly being aware of all the surrounding where things are happening, and our first HTTP function in queue a message, and this is the function that will dequeue a message and so forth. So you can see how simple it is. This was function, this was bindings, and I say we have other bindings, and later on we have like a more detailed, more in-depth of functions, so we'll be able to see how functions are behaving. All right, so having fun with function, we have fun with functions, good. So app service is great. We have pretty much over 400,000 active customers. These slides are slightly old. Closer to 400,000 cores or VM, more appropriate. Tons of applications, more than 10 billion requests a day, so we can handle all the traffic that you guys can throw at us. The second most used service in Azure in terms of number of subscription or number of users using the service. Okay, so next what I want to do is I want to dive into a demo that we have, which is it's a conceptual demo that basically ties a bunch of services and a bunch of Azure services into one scenario. And I'll just walk you through the scenario, and then we can just go through one through the different aspects and see some code and see how things are handling. Hopefully, it will just tie in like the fact that we have a platform versus managing infrastructure. Okay, so what we got is we have an insurance company. This is Compressor Insurance. Compressor has a lot of holding companies. It's a holding company, has a lot of branches. So one of them is Compressor Insurance. And what Compressor Insurance has already existing assets is the thing that is at the bottom here, the green bar over here, which is basically existing, let's say, a web MVC web app application which runs on premises. This is internal application for claim adjuster to approve, disapprove, do whatever you want with an incoming claim, right? And they used to be able to submit claim in the past. You would be able to submit claim with whatever, to an agent or God knows how. Okay, what Compressor want to do is to modernize the process to be one of the good company insurers out there, I guess, and allow customers to submit claims through a mobile app. So what we built for them is basically we created a Xamarin Form mobile application that basically allow you to authenticate as a customer, be able to identify which vehicle had an incident, be able to take all the details that you need from the incident, and then basically submit it. Now, the thing here in between is the Azure backend. This is the piece that glue between the cloud, because the mobile application would probably always run on the cloud versus on-prem, and be able to handle all the logistic of moving data from one piece to the other, running through automation of claim adjuster, connecting to on-premise, running some workflow, and be able to interact with the customer. And if you need, you basically feed in everything, obviously, to the on-premise, and the claim adjuster can approve, disapprove, if it's not automatically approved for you. What we got behind the scene is this. A user basically running a mobile application. There is an auth dance here with Microsoft account. We'll see it in a second. And the user basically can submit information. The way we're doing it, we're using Azure Blob. Once you see the code, will be much easier. So a mobile application basically uploads information to the cloud. We are triggering events from the blob that basically kick up a workflow that either automatically approved or reject the claim. Approve or reject. If it's rejected, then basically it goes into the claim adjuster, and the claim adjuster can just basically manage everything from here. And what happens, the workflow is basically we handle mobile claim, we do some, we do some OCR, we analyze the information that comes in, goes through the flow. There are some logic applications here where you can see Office, we send emails and so forth. So I think it's just easier just to be able to just see it in action. All right, so now I need to turn off my Mac. Okay. Right. Cool. So let me just go through the demo, and then we can dive into the little applications here. Running on the Mac because it's a lot easier to run the iOS simulator from a Mac than running it from the Visual Studio tools. But you get the idea. So this is the app. Already logged in. I started the code for login, so you actually can believe me that I've done that. But I have 2 vehicles. I'll choose one of them. I'll go ahead and basically now being asked a bunch of questions to fill. So for example, the license plate of the car. So I guess this is the second car. So here's the license plate. All right, so we move on. The insurance card. Let's look at the insurance card. Here's an insurance card. We hit next. Driver license. You can do that as well. Here's a driver license. Phone number. And one too much. Should just be nicer. This actually doesn't let me to print. But anyhow, images. So I can go ahead and do some images here. I don't know. Let's take the one with the red stripe, so it's easier. And get another image if we want to. Let's pick this one. Fine. And then some notes. Demo at Tech Summit Chicago. And I'm done with the notes. And basically now I hit that. And what happened here is the application now is doing a bunch of stuff, accepting the auth. It's basically preparing a package, uploading into Azure Blob, and then be able to signal the application basically, hey, I've uploaded everything. We are ready. Just start the workflow. Takes a bit, teeny weeny, too long. All right, submitted. And this basically started the workflow. And now I'll just go back to my PC because I'm more accustomed of running my demos on the PC. Okay, so I think I have here, yes, okay. Okay, so this is the behind the scene. Cool. So what happened is that we have a very sophisticated algorithm to approve or reject claims. Basically, first time we see your name, we auto-approve, and then we just auto-reject. Yeah, very sophisticated. So let me search and see. Hopefully, there should be new claims coming up. 16 was already there. Need to log in again. All right, search. And here is 17. And the reason I'm doing it in, the reason I'm connecting in an incognito mode is because, maybe I should show this to you. I logged in with Emily B, which is a specific, and we have an Azure tenant ID. I'll show you the whole behind the scene, the whole thing. You can see here, actually, this is the Outlook for Emily. And you can see I'm running on Compressor Insurance. I hope you guys can see. Now you can see better, maybe. So the whole thing is based on that tenant, and this is how we do the authentication from on-prem. And we also allow Azure Active Directory allow external customers as well. So this is how I can, for example, my name is being picked up from my Gmail account in this case. And you can see here that hey, claim 17 was created, which is the last one. This from 3:26, which is I guess the clock time in Redmond. And that's it. And now you can click on the link, and you'll end up basically deep linking into the claim. And claim 17 is right here. And this is the claim. And you can see that's the notes and the description. These are the right images that I've passed. You can look at the second party information, and you can see the images that have been submitted. And we are running, I'll show you the behind the scene, but we're using Microsoft Cognitive Services and running OCR to basically identify all the information, just pick it up automatically. And that's the whole thing. And now I can approve or reject. It doesn't really matter what I do. This will just kick in a different workflow that can go ahead and figure out what needs to happen. And this sends an email, hopefully works. And yeah, claim rejected. Cool. OK, so let's go in and look into what's actually being comprised to build this application. We are OK on time. OK, so this is the entire app, basically, in terms of all the resources. We have an Azure resource group here that basically identify all of the items that we got in that application, and there's few of them. Basically, I have a web application, mobile application. Basically, is exposing a set of APIs for the mobile app. We'll see the code in a second. I got the internal application. This is the MVC app. I got storage account. We're running with application insights. We have 2 logic flows. We saw one of them in the previous demo. We're using multiple databases. You're using event notification for event hubs for popping up messages. You can see API connectors here. These are some of the connectors I'll show you with the Logic app. We use GitHub because we're using deployment automation here. We're also using Office 365 to be able to send and receive emails, as you would expect. All right, so I'll open my cheat notes to figure out exactly what's the right order of showing you all the lovely moving parts of this application. Right. OK, so one thing I want to show you, for example, is the API. So on the API, it just, as I say, this all looks the same because these are all basically underneath the cover the same web apps at the end of the day. What I want to show you specifically is the authorization authentication piece. And as you can see here, it's allowed to allow with on. And allow basically to connect. And there's, I got some advanced setting in terms of the token store and how to manage this. And basically, it's configured with the Microsoft account. And you can see here all the tenant information, all the signing on. And this is the signing information that you basically get back from when you sign in with your mobile account. This is the data that we actually collect from the token with the identity provider. You can collect multiple of them. And obviously, when you do the first login, it asks you which one do you agree or not, and so forth. The nice thing about Easy Auth in terms of this is that this entire thing is being managed at the platform level. You don't write any backend code to actually make it work. And I'll show you and prove you exactly what I mean. And to do that, I'll just go really quickly here. Never mind. We'll use one of them. Doesn't matter which one. OK, so what I got here is a different app, which is easier for me just to show this one's particular feature, which are awesome web app, which is just a way to demonstrate all the features that we have, just one big pile of app. What I want to do is, you can see it has a custom name and so forth. Really quickly, just go into custom domains, copy this, go here. OK, so this is the app that I got. This is this dynamic information. You can see here like machine information I'm running, so I can show you scale. I can show you staging environment, a bunch of stuff. Specifically for Easy Auth, this is the Easy Auth piece of the data. Cool, and I'm not logged in right now. And this is the information I can pick. So let me just quickly show you what I mean. So I'm running with Easy Auth. It's on, but I allow anonymous application, anonymous access, basically. And this application is configured not with Microsoft account, but with an Active Directory. And it's configured in Express. And the other piece I'll show you what does advanced mean. But basically, this is just creating a tenant within Azure Active Directory, and I can hook it up into it. All right. So if I go here and log in with my Azure AD, because I'm already logging to the portal, it doesn't allow me, it doesn't ask me actually to authenticate anything like this, and I can go back into the application, and voila, this is authenticated successful, and you can see it picks up all my credentials, the token, all the information that you need. And when I show you the code for that, I hope you'll agree to laugh about it. So let's see. So this is the MVC app for Awesome Web App. This is the code. See a bunch of controllers. So if I go really quick to Easy Auth controller, you see it's very complex. You don't even need to see it. Agree with me, very complex. So there's no magic happening on the controller level. At the view, the only thing I'm doing basically with the view is I'm going through, and because the Easy Auth basically is an IS module in the pipeline. So it's in the managed module, we capture we do the interception, we do everything, and then we inject all the credential. And basically everything within the system security and the claims, and with the claims and the principal are just there for you to work with. So we make all the injection, and here it is, and basically I just enumerate all of them here. So there is zero code for me to actually handle that kind of level of security, or authentication, sorry. And this obviously adds a level of security. So we're doing the same thing with the mobile app. And where was I? See, too many windows. And with the mobile app, basically, if I really quick the mobile piece, so this is the mobile application. And where is my mobile helper? I am on the helper, sorry. So to do the logging, basically, what we got, what we have, I'll just try to explain it a little bit. Basically, this is a Xamarin just to get dependency. This is how because each mobile device will have its own different way to interact and handle the token and where to token and store them. But behind the scene, what we're having is a Microsoft, the service authentication, which is part of the SDK. We're going with the Microsoft account, and we're doing the login. This will basically pump up the login on the mobile device. And assuming everything is successful, and with those 3 lines of code, you've just logged in. And on the server side, once you enable Easy Auth, as I saw you, there is no extra work that you need to do. So that's all it takes. And now you're basically authenticated into the platform. All right, so that should be cool. So that was the authentication piece. Let's see. Actually, I think I have slides to help me with the, so Active Directory. Okay, we talk about Active Directory. So we have Active Directory in the cloud. It can connect. On-premises connectivity, obviously, to the cloud, different providers. And then you can have your application to be able to authenticate. Office 365 is just one example. You saw I can integrate with a bunch of other. We've seen the demo. All right, next. Offline sync. So offline sync is also really cool on the mobile app. We provide, again, the SDKs on the mobile to be able to handle offline sync. And offline sync is important because sometimes you had an accident, I don't know where, and there is no connectivity. So you just run the application as usual, take all the information, you can actually click the done. We're not able to connect, but it will wait for next time. And what our handle offline sync will do for you is basically manage all the transaction for you on the client, and we have the server-side piece as well. So we have the mobile SDK. On the server side, we have a table controller or Easy Table for Node, API controller or Easy API, again, for Node. And you'll be able basically to work again any data source, including blob storage and SQL database. And you can define all that both in both of the applications. So I think really quick, I'll just show you really quick the code because it's a little bit hard to just show the actual demos behind that. So I'm still on the server side, and mobile helper. No, this is the client side, sorry. This is the server side. Okay, so on the server side, basically, what I got is the following. Just I wanted to remember some of the stuff here, like client submitted. We'll see it, and we'll see this in a second. But the claim controller is more important here. So what we do in the claim controller is, where's the claim controller? Oh, come on. claim storage controller, sorry. What we do in the claim storage controller is basically this. We go ahead and we ask for a storage token. Because what happened is this. The mobile application requests a storage token because I don't want to upload all the images and the package basically through my MVC controller. Doesn't make a lot of sense because it's just gonna read the information, so that's one thing, goes to the CPU of that VM directly, and just the only thing that we'll do immediately directly is save it to the storage. Instead, Azure Storage has the ability to create token, SAS token, access token basically. Once I create them, I can grant access, reader access, write access to my mobile application, again, authenticated. And now it will upload into the blob directly, not going through my servers. Saves a lot of bandwidth, saves a lot of CPU, saves a lot of money. And it's a little bit more reliable because now we can actually handle the offline sync to do the song and dance that takes care of all of that. So obviously we do the authentication, we get the thing, we get the token. Once it's ready, we return it to the mobile app, and the mobile app will go ahead with the claim, manage the claim. This is basically, yeah, I'm going to go through all of the information. Basically, we have a claim table async. You have a vehicle table async. This is basically table records that are matched. There is a SQLite running on the mobile. Then again, you can do the sync against actual SQL. All the metadata is there, and we add a file with the metadata. Once the device comes online again, it's immediately try to sync, identify, hey, I got new records here. I'm just going to start uploading them, and so forth. So that's how the offline sync works. Once we get the offline sync, what happens is we basically start handling that. And specifically, the function is being notified that, hey, there is an activity, and then the function is the one that actually kicks off the logic workflow. But let me just quickly walk you through the logic app. As I say, tons of connectors, and this is just a partial list of all the connectors that we have. Obviously, you can see a bunch of Microsoft assets, but there's a lot of SaaS services out there. Sorry, a lot of third-party services that are supporting that as well. So let's look at the auto-approve for a second. Let's look at the manual rejection, because I just rejected one. So this is the one that we ran just right now, right? You can see the request coming in. You can see my private email information here. You can see correlation ID. I'll just copy that for later. And basically, you can see handle the manual claim because we say, hey, manually we rejected. You can see this is claim 17, the new claim that we created, and so forth. Was it approved? No. Then send an email and do a bunch of stuff, other stuff. Here's if it's approved or if it's not approved. Do something, you can see the send email. You can actually see the entire thing. You can see the body, all the data, and so forth. And this information comes from the push manual reject function that actually handled that for us. So there is a combination of Azure functions and logic app to be able to complete this workflow. Nice thing about function, as we saw, it just basically, once you write them and they run, you don't really care where and how they run in terms of management. We copy the correlation ID, logic. I think we're good. We saw that had that work. All right. So I think next I just want to go and actually show you some of the functions in here. And obviously, this will be a much more complex function app with many more functions and many more supported files than the simple hello demo, the hello world that I show you. And hopefully, this will just convey the message that Azure Function is like a substantial improvement of writing code. So basically, handle new claim, handle mobile claim, as you can see here. I'm not going to go on this. We'll go a little bit later. But basically, it's identify. There is all the information coming in. For example, the claim itself is being handled. All these iCloud blob is basically object into which then I'm going to get all the images that we need to do. Handle mobile claims specifically. Goes into here, runs, get ARM. I think I want to show you this piece specifically. So this is the one that is doing all the work with the OCR. So OCR update sync. What am I showing you here? Let me show it to you. Let me show it to you here. It'll be a little bit easier. Okay, so so these are all the functions that we got. This is the project for the functions. Handle mobile claim, as I said. This is the run method. You can see some telemetry information here, a function triggered. We'll see it in a sec, how it actually handle the mobile claim. Goes again to another function that just manages. You get all the CRM claim, the database, and do the updates. What I want to show you is all this information, and this is where we're actually going to do all the work of analyzing the data. So we basically run an OCR on each of the images that we have, like the card. I guess it's the insurance card or the license and the license plate, and then all the other images. If you scroll, so this is under OCR, and OCR is another file over here. As you can see, you can nested multiple classes, multiple objects with functions, and this is the OCR. And this is basically using Microsoft Cognitive Services, specifically Vision to run the OCR. We extract environment variable. We use environment variable to hold the keys instead of saving keys and secrets in code. And basically, we just run the OCR client to be able to get data. Once we have all this information, basically, it just continues to flows into the logic and so forth. Logic functions. We've seen some of the functions. OK, we've talked about that. Cool. Actually, I should have shown this before I show everything else. I apologize. So, but I think we've seen a bunch of that already. So, as I said, there are different triggers. There are different input. And as you would expect, you would be able to use those constructs. When you're creating a function, you expect to have input parameters passing. So as you can see here, in this example, it's like a hearable of a class of image. This is running from an actual input, our storage table. There are blob objects over here. You can respond and output. And everything is being declaratively on the binding. So you can obviously put it into source control, and you can manage DevOps around this. And as you would expect, input table is an object you can work. You can iterate around this because it's archivable. And actually, you can work with image text, which is part of the image text object, and actually manage that. It's a different application, but you get the idea. So when you go here to the code, you can actually fill that if we take like an auto-approved claim, which I think is a little bit simpler. But you can see here the HTTP request information coming in. We deserialize the claim. We work it out. We create a response. This is where we approve or disapprove the claim. This is where the magic happens of the simple if-else that we got and so forth. So this is basically Azure function in a nutshell. You write a piece of code. You basically deploy it, and it just runs, and it will scale as much as needed. You don't even manage the servers or anything behind the scene for that. OK. So now what I want to show you is, other than the demo, I want to show this. Yeah, OK. So before that, let me really quick go here. This. For those who are left, who decided to stick around with this session and didn't get bored already, what I want to do is I want to challenge you a little bit. I want you to take up your phone and send an SMS to this number and tell me, I don't know, how do you feel? How do you feel about the session? How do you feel about my presentation? How do you feel about this day, this event, Azure Function, Azure App Service, Azure in general, whatever you want, just send SMSs and see what happens. And while you're doing that, I'll go here, and I'll just basically show you what I'm doing. This is a little bit simpler functions than the one that we've just seen. Maybe it will help. So what I got here is basically a webhook. And when you send a message, it goes to Twilio. and basically Twilio sends me a web notification that I'm handling, and all I'm doing is just, for example, taking all the query information and just breaking it apart, creating some object here that I can work with, and get the information, like the body of the text from who to whom that you send, some metadata information about time, events, when it happened. And then I'm writing it to a queue. We already seen it. It's very simple to write to a queue. Once I get it on the queue, I have another object here, another function here, sorry. Similarly, this is using the Project Oxford, which is Microsoft Cognitive Services. I'm using sentiment analysis in this case. I'm creating all the object here, whatever I need to do to use the sentiment analysis. Same thing, I'm taking environment variable. I'm not sticking keys in my code. And I get the data. I run the sentiment analysis. Here's the score. I can actually run logs so I actually can see things flying all the time. And then I go ahead and send a response back to the SMS. And this is where I can show you function and binding a little bit. So let me just, these are all the people that I hope send information now. We can see it in a second. If I go to the integrate, you can see I'm actually sending outputs here to Twilio and to DocumentDB. So Twilio is a third-party service. We work with them to create this binding. It's very simple in a nutshell. This is the binding information. They expect some keys like the SID and the token. These are environment variable. These are the basically pointer to the data itself, the secrets themselves, and those are environment settings. DocumentDB, the same thing. I have database and a collection, and this is the connection string. And if you look at the code, rather simple. This message now, this SMS message already includes the score, and basically I'm just sending in a response and writing to my DocumentDB, the queue item, and that's about that. So really quick. And the algorithm to making decision whether you get a smiley face or a set is basically just based on the sentiment analysis, just a range. It's nothing too complicated or fancy. But this is it. I mean, this is the three functions that I wrote here. And I'm using Twilio, which I have no idea how to use. I just created a Twilio account. And used the binding. And read a little bit of documentation around that, but I didn't bring the SDK of the Twilio or anything like that, and it just works. So the idea is like three functions, and you got this funky little demo that sends smiley faces, but you would agree it could be interesting. So this is the DocDB, and what I want to really quickly just show you is the information, which is quite cool. Just quickly bring up my notes. So let's just get all the guys who send good stuff, otherwise it's going to be a shame. So here run the query, and this is maybe from earlier today. I already ran, as I said, the function. But these are all the people that replied. They were nice. And you can see the data, what they have sent, the score that they've got, the ID, and that's it. And I guess if I scroll down here, you're probably going to see, this was long, man. Cool, thank you. Good score. I don't know her, but thank you very much. Yeah, lots of great info, cool demo. Yeah, so you see the idea. So pretty cool. There's all the info. By the way, I'm only augmenting part of the information here because I do collect all your phone numbers. No, I'm joking. I actually need to fix that part of the demo just to keep the last four digits. But anyway, you get the idea. All right, so I want to show you App Insights really quick because I think it's super cool with what it can do in terms of just tying everything together that we've seen. I'll show you App Insights. It was part of the Logic app. It was part of the function. It was part of the API. So this is actually traced across all of the different services that we've talked. And I can use App Insight to run through all of the information that we have, which is really important. You can collect telemetry for every tier, right? From your mobile application, from your web application, from your API, from your Logic app, for your function across the board. Project the telemetry. and show some information around it. So what I want to show you now is how we're doing that. And actually, I need. I need one of those. I hope this was the last one I've used. And the reason I need it, basically, I just need to copy the correlation ID again, sorry. And I'll go to my, this is the analytics. Already I can get through it from my resource group, but this is just easier like that. Let me open up a query already created. So this is the correlation ID, and remember I told you to remember some sentences or phrases from the different telemetry that we are putting out from logic or from functions or from the API itself. So what happened is we are basically pulling up we are emitting telemetry information for every single step that we have. So this is claim received from the mobile app. This is a claim that was received from the mobile app. I got the message, it's in the blob. Now actually in-queue, the mobile application notify the backend to in-queue a message into the queue to actually kickstart the entire process, the entire workflow. And the function was triggered, and then the data was required, and then the insurance card, and this is the OCR, before, after, before, after. You can see all the data here. You can see all the eventing and the time it takes to all run through the information, and the auto-approval was rejected, and then all the information here, and then the claim was manually rejected because it's what I did, and so forth. So from every single layer of the application, everything is traceable and manageable with App Insights. And what's cool about Insights, again, it's a fully managed application. So everything I showed you thus far, I can deploy all of the web API and the mobile application. The backend, obviously, you can use Git deploy, which we are using, or Visual Studio deploy, and the logic app, as you can see, and it's basically you can do it. You use the portal. You can use Visual Studio to create, but there is no server behind logic app. There are no server behind functions. Everything that you've seen thus far is fully managed for you, and this is the beauty of the platform that I say. And with the last 7 minutes, what I do want to show you is just a little bit of what actually happened behind the scene with respect of the actual apps. So we do have something that we called an app service plan, which is a logical representation, I would say, of your VM that do run your backend, because the mobile backend and the API, the MVC applications are running on a standard, in our case, a basic single small VM of app service, again, fully managed. If I run on 3, it will just scale and run on 3 automatically for me. What I want to show you is basically, we got the information here. We can do the scaling alerts. For example, these are alerts that I can configure. So I can say, like, hey, if the CPU ever goes above 75%, send me a notification. You can see there was a little bump here, maybe restart of the application. Memory is kind of constant, and you can see here. Obviously, there's no load on this app. It's a demo app, but you can get the idea. If there are too many errors, so this was a view for those memory and CPUs or for the app service. This is a view of my actual app. So this is for the API, which the mobile handle. If there are any error, there's a 500, I'll get notified. And you can actually create a webhook, and I just show you what you can do with function of a Twilio webhook. You can imagine what you can do here furthermore. So this whole thing is trying to say is like fully managed for you. The whole orchestration happening behind the scene. You don't really care for any of that. You can scale up. You can scale. You can have automatic scale happening for you, and all this is really nice. And yeah, I think I can talk more for a couple of days if you really want. But we have 5 minutes. We have beer waiting for us, and I don't want to leave room for some Q&A. So even if I have a few more slides, just articulate some of the flow here. Let's just finish with this. So basically, I build my code, push it to GitHub, automatically being deployed, put it in a pre-production environment, staging environment. I haven't shown you in this part, but trust me, it's there. I can run load tests. I can run functional tests, whatever I do. You can imagine there is a whole flow here until it actually works, and and I can push it into the production. Once you move into production, we safely allow you to actually make the transition, so there's no downtime. We take care of that for you as well. You deploy it on the cloud, everything is happy. Use a pin site as I showed, or Hockey app for the mobile, we use that as well. Collect all the telemetry and information, figure out where you are, and the cycle continues. All right, so there's actually a bunch of other slides, but those are boring slides. So I'll finish up with questions, and I'll just leave you my contact information if you care. If you want to have other questions you want to ask for publicly, I want to thank you guys for sticking around until the end of the session. Thank you very much, and I hope to see you in the Ask the Experts.